Hello and welcome to Bay College's Intermediate Algebra Online Lectures. In this video, this is section 9.3. We're going to talk about distance formula, the midpoint formula, and how they relate to circles. The first thing we're going to look at is the distance formula, and the distance formula is nothing more than a variation of Pythagorean theorem. Hopefully we recall a squared plus b squared equals c squared. Now, if we're given 2 points, we can find the distance between those 2 points because every point has an x value and a y value. If we look, we're going to call this our x1 and y1, our two values there in our points. x2 and y2 are other two values for that point. Well, each one has a corresponding x value. So to go from this point to the next point, I have some change in x. And to go from this point to the next point, I have some change in y. So we change our x's and change our y's to get to the other point. So we can see, in a way, it creates a triangle, a right triangle, our values of x's and our values of y. So that's why Pythagorean theorem will work to derive the distance equation. So essentially what I'm going to do is I'm substituting in, instead of c squared, well, I'm going to look at my distance squared is equal to the changes in my x as my a squared, maybe the base of my triangle, and the b squared are my change in y, the height of my triangle. So we have our base and our height, or our a and our b's. All right, if I take the square root of both sides, as we've seen in Chapter 6, we dealt with radicals and how to work with radicals, and we've seen it again in Chapter 7, dealing with squared terms or parabolas. Now, I'm not going to worry about the plus or minus when we introduce a square root here because we're dealing with distances, and distances can only be positive. So distance equals the square root of my change in x squared plus my change in y squared. This is the distance formula. So if we consider these 2 points, 2, 3, and -4, -1, we can find the distance between these 2 points. So essentially, I'm going to use the distance formula. Distance is the square root of my change in x. Well, how do we find the change in x? Well, we can say, if we call this point 2 and this point 1, the change in x is 2 minus a -4. 2 minus a -4, well, we subtract a negative, we get positive, is 2 plus 4, plus the change in y squared. Well, I have 3 minus a -1 is 3 plus 1 minus a negative again. And if we simplify this, 4 and 2 is 6. 6 squared is going to give me 36. 3 plus 1 is 4. 4 squared is 16. And if I add these two together, I'm going to get 62, or excuse me, 52. Now, we could simplify this a little bit. 52 is 26 times 2, so let's just factor to get here. And 26 is 2 times 13. So we have a perfect square under this radical. And I'm just going to write it right here. So we simplify our radical, as we did in Chapter 6. 2 times 2 is 4. The square root of 4 is 2, the two factors, right? Square root of 13. This is the distance between these 2 points. So I have found the distance. All right, now we're going to look at midpoint. What is the center value on this? Without graphing, we can find it algebraically. So we're going to move over here and look at the distance formula. To find the midpoint formula. To find the midpoint, what we need to do is we need to look at the points 2, 3, -4, -1. And the midpoint formula is the sum of the x's divided by 2, and the y is the sum of the y's divided by 2. That's going to give us a point that is the middle of these 2 points. Now, if you think about it, you already know this. If you're at this point in your algebra career, we're essentially finding an average. If we have 2 values, we can add it up and divide it by the number of values. 2 values divided by 2 gives us the average. So essentially, you don't have to memorize the midpoint formula. You just have to think of it in terms of, I need to find the average x and average y to find the middle ground. All right, so let's do this. Let's use this. If I'm going to find the average x, I'm going to say, okay, let's start right here. If I say, okay, -4 is an x value, plus 2, my other x value, I have two values I'm going to divide. This is going to be my average x. Let's find the average y. I have -1, and I'm going to add to it this y value, which is 3, and divide it by 2. My average y. And if we just do the math, -4 plus 2 is -2. -2 divided by 2 is -1. And -1 plus 3 is +2. 2 divided by 2 is a +1. -1, 1 is our midpoint. Let's go back to our graph for a moment here and say, okay, if my midpoint is -1 in the x, +1 in the y, we just found our midpoint. We can see, yep, that line, just from spatially looking at it, is right in the middle. So the midpoint is -1, 1, our midpoint. And I'll abbreviate that MP. So just keep in mind, to find the midpoint, we can do that simply by finding the average x and average y. If you take a physics course, sometimes you're going to have to find the center of gravity of an object. And that's going to have more than just one xy point and another xy point. Maybe it has 3 or 4. Well, you can find that center of gravity by doing an average. Average all the x values, average all the y values, and you can find a center of gravity. Some of them might even be weighted averages, but it's the same concept. So let's move over here and see, how does this concept of distance and midpoint deal with circles? What we're going to do is we're going to find a circle. And if you're following along with the notes, we have, let's consider a fixed point HK. And any other point xy. And I just put a point out there. We're going to call it xy. And we're going to call the distance between them r, which is going to stand for our radius. And we're actually going to build a circle. I want to find what is the distance to any point xy r units away from hk. So what we can do is we can use the distance formula. So I'm going to say, instead of d, I'm going to say r equals the square root of my change in x's. Well, I do have 2 points here, xy and hk. So my change in x is going to be x minus h, my change in my x values squared, plus the change in my y value squared, y minus k. And hopefully we recognize these h's and k's from previous sections when we dealt with parabolas and vertex. It's the same notation, essentially. And then I say, okay, well, I want to get rid of this squared value. If I get rid of this squared value, I get r squared equals x minus h squared plus y minus k squared. Because this is a distance, how far points are, we don't have to worry about the negatives. It's plus or minus. Well, in this case, we're just looking for positive distances. We don't care about the direction. Is it positive or negative? It can be either direction. This essentially is the equation of a circle in standard form. Many of us like to see the equal sign on this side for our equation of circles. But this is our circle in standard form. And if we see a circle in standard form here, it gives us a lot of information. We could say, hey, the center is hk, and any value is going to be r units away. Be careful, this is something squared. So if you see, as an example, 25 here, realize that the radius is 5, right? Because what squared would give us 25? So what this tells me is if I go r units in any direction from my center hk, as long as I'm r units away, I will build a circle. And I apologize that it's not a perfect circle. I was freehanding it there. So this here is your equation of a circle. So let's go to this here and say, how can we graph a circle in standard form? This is a circle in standard form. If I look at it, I can determine what h and k is, and I can also determine what r is, my radius. So my center of my circle, HK, what am I subtracting from x? Well, if I look at it, it's just x squared. So my h value is 0. X minus nothing is going to give me x, that quantity squared. Well, if I look at this, my k value, what am I subtracting from y? Well, because this is positive, and if we recall from parabolas, it was always the opposite of what we saw in the grouping symbol before we squared it. That holds true here, but now it's a k value. So it's y minus a negative 3. That's how we get that plus 3, so k is a negative 3. This is the center of my circle. So if I want to find the center, I just need to know the point HK. All right, so we're going to put that on here. I'm going to go 0 in x, which is right here at the origin, and down 3. This is my center, 0, negative 3. Now, how far is my radius? Well, I always have to remember, if it's in standard form, this is my radius square. So what value squared gives me 4? Well, I know that that's 2. It's nice when they're perfect squares. When they're not, we deal with the square root of something, which can sometimes be not nice when we go to graph it. So 2 units is how far any point on this circle lies from the center. So to graph that, I'm just going to go up 2, because 2 units away. I can go down 2. I can go right 2. I can go left 2. As long as I go 2 in any direction, I'm going to find a point on the circle. If I go 2 in this direction or 2 in this direction, it really doesn't matter. But I just want to put enough points on here so that I can draw my circle. I just graphed the circle x squared plus the quantity y plus 3 squared equals 4. That would be the graph of the circle. Now, it's really nice when they're in standard form. We can just look at it and say h is this value, h is this value, the radius is the square root of that value. But what if it's not in standard form? Let's look at this next example, which gives us a circle not in standard form. The tool we need to bring to this in order to put it into standard form to find our h value, to find our k value, to find our radius is completing the square. It's very important to know how to complete the square. You have to master it because you're going to use it all the time. It is the only tool that you can use for completing the square. Well, the only tool for this class. All right, so to complete the square on this, I'm not just going to do it once. I actually have to do it twice because there's x's and y's. So I'm going to complete the square, but before I do that, I'm going to do a little bit of accounting, bookkeeping. I'm going to group my x values, and I'm going to leave a space. And then I'm going to group my y values as well. Just get everything in order. And I'm going to leave a space. And then I'm going to write my constant over there. I have to complete the square on this. So in order to do that, I have to recall completing the square. It's 1/2 b. 1/2 b squared. Hopefully we didn't forget that. So my b value is 6, so I'm going to take half of 6, which is 3, and I'm going to square that value to get 9. Add that value to my x terms, because I'm only completing the squares on my x terms. All right, let's have a plus symbol in there just to separate it. Well, if I add 9 to this side of the equation, I also have to remember to add 9 to that side of the equation. So now this piece, my x values, is a perfect square, hence completing the square. It's going to factor really nice to x and whatever this value is here. Now I have to complete the squares on the y. This is where we have to do it a second time. So I'm going to look at this, and I'm not going to show the work, but I'm going to explain it. It's the same as before. My b value is -4. Half of -4 is -2. -2 squared is +4. I add this value to this side. I have to remember to add the value to that side. Now that's a perfect square of y minus 2. That value, half of this, before we squared it, was -2. 3 plus 9 plus 4 is 16. We now have a circle in standard form. I can look at this circle, do an assessment, and have all the information I need to graph it. Well, the first thing is, what is the center? Well, the center is the values h and k. It's always the opposite of what's in here, so my h value is -3. It's always the opposite of what I see in here, so it's not -2, but +2. That is the center of my circle. Well, what is my radius? Well, my radius is the number squared that gave me 16. Recall, it's just like Pythagorean theorem. A squared plus b squared equals c squared. Well, what value squared gives me 16? 4. So the radius is 4, and the center is -3, 2. Now we could just take this little bit of information and go over to a graph, and we can now graph this circle. The first thing I want to do is find that center. -3 in the x, +2 in the y. So there we have our center, -3, 2. All right, and maybe that's going to get in the way, but if you're asked to label your center, make sure you do that with the actual point that is the center. Now, my radius is 4, so I want to go 1, 2, 3, 4 in this direction. I can go 1, 2, 3, 4 in this direction. And I can go 4 up, 1, 2, 3, 4. I can go 4 down, 1, 2, 3, 4. And I have all these points here that I can graph my circle, and hopefully it looks somewhat circle-ish, if circle-ish is a word, right? So we have our circle. Any point on this circle from the center is our radius, 4 units away. So this is 4 units away. This is 4 units away. This over here is 4 units away. And we can kind of see how we can use this version of Pythagorean theorem to actually apply this to circles, because circles is considered an infinite number of triangles. If I did want to find this point here, to get over to that point, we have some value in x and some value in y that is r units away. No matter where it is, we can set it up as a right triangle and find that x and y value to give us this point, some x and y value. So this has been section 9.3, distance formula, midpoint formula, and circles. Thank you for watching.